calculus lesson on antiderivatives. So yeah, here it is, guys. The definition: a function capital F is called the antiderivative of the small f on the interval I if the capital F prime is equal to small f of x for all x in the interval. Okay, so if that's the case, let's take the derivative of this, which will represent, according to this, f of x, right? And when you take the derivative of that, that gives you 2x. Now, the question is, what are the kinds of functions we'll have derivative of 2x? Let's say we have capital G of x is equal to, I don't know, 2x plus 1. Then G prime of x will be 2x. And we might have another one here. H of x is equal to 2x, oh, I don't know, minus e, right? Then h prime of x, it will be just 2 to the x. So what that means is that there are functions that are the infinite variations of that, and all of them, right here, guys, has to be some sort of constant, right? Right. So that's what the next theorem basically says, is that if the f, capital F, is the antiderivative of the f on the interval I, the most general antiderivative, the most general, guys, antiderivative of small f on I is capital F of x plus c, right? So the f of x, if you think about it, is a ddx of capital F of x, isn't it? When you take the derivative of that, that's f prime of x, right? So you could have the c here, any kind of number, and that would be the antiderivative. That would be give you a legitimate antiderivative of the small f of x. Okay, so c is an arbitrary constant. Okay, guys. So let's talk about the antiderivative of ln of x. How does that work out? Okay, so we know that the f of x equal to ln of x, absolute value, is defined thusly. That is ln of x if x is greater than 0. And then we got ln of negative x if x is less than 0. Yeah? Okay. Then what is f prime of x? Well, if you think about that, for the x greater than 0, when we take the derivative, it's just 1 over x times 1, because the derivative of the x is 1. You should apply the chain rule. And then for the second one, when x is what? Less than 0, that is 1 over negative x. The derivative of the negative x is negative 1. So in both cases, therefore, right, the f prime of x, which is ddx of the ln of absolute value of x, right, has to be 1 over x. All right, guys, there it is. So let's harken back to the power rule. And we know that when you take the derivative, it gets 1 times x to the n minus 1. But question is, what happens when you go the other way, right? Okay, so let's think about this for a second. So if I were to have, let's see, how does it go? How do I get, so in order to get n, if I take the derivative of something, I have to have n plus 1, right? And then I would actually have to have what, right? When you take the derivative of that, it would have created n plus 1 in the front. So to cancel that, you got to have n plus 1 in the bottom times some number k. Okay, so let's just check it out. So if f prime of x with that, let's check, all right, is k times n plus 1 times x to the n, and then we had n plus 1 in the denominator, right? That cancels out. Yep, that gives us k times x to the 1. All right, guys? All right, this is good exercise right there. Going to the next set of questions, we have, I gave you a partial list of the antiderivative formulas. This too, we're not going to do. It's not part of our AP curriculum. And you notice that we have inverse trick, but we didn't write that for everything, right? So that doesn't mean that you should remember them. I'm just telling you that they're reminding you the most common ones, but you should also know that for inverse cosine, right? Inverse secant and all that good jazz. Okay. If you notice, we only have sine, cosine, tangent. That doesn't mean that you don't memorize the other stuff. The good way to think about the antiderivative is think about doing derivative backwards, right? Then it's not a new thing, right? We're doing just a new thing. It's a variation of the old thing. Okay. Right. Let's do some problems, shall we? Let me slide this up one at a time. Right. So, what to do? So to make things easier for ourselves, right? Let's do this, shall we? There you go. Let me just slide this up just a tiny bit more, right? There you go. Okay, this one right here, you should be thinking about that as 5 to the x to the minus 4. This one right here, guys, you should be thinking about that as x to the 1/2. That will make things a little bit easier, okay? So you should be thinking about this. You don't have to write it down. Uh, if that is not good enough for you, you could just write down the whole thing with this new expressions right here, like down here somewhere, okay? But I'm not going to do that. Okay. So the antiderivative of the f of x, we're going to write as capital F of x is equal to, what do I do now? Let's see. We got 5 x to the negative 3 divided by negative 3, right? You're adding 1 to the negative 4 gives you negative 3. And then that is just e to the x, right? And then what derivative? Oops, that should be a square, but okay. Sorry about that, guys. Depending on which version you downloaded, the notes, some of them have a square, some of them do not. I apologize for that one. Yeah, what derivative gives you secant squared? And that is tangent, right? Okay. And then for the next one, we add 1 to the half, which gives you x to the 3/2. And we're going to divide by 2/3. But pretty soon you're going to get comfortable just writing the reciprocal of 2/3 in the front. All right. So we say, therefore, f of x, let's clean it up. It should be negative. Okay. So hold on a second. Did I do this right? Negative 3. Yep, it is. So that should be negative 5/3 x to the 3rd minus 3 times e to the x plus 7 tangent of x plus 3/2 x to the 3/2. All right, guys. I hope that worked out for you guys. All right. Okay, let's move on to the next questions, shall we? All right. So the next set of questions is right here. What to do, what to do. Okay. We should simplify this thing, shall we? This thing right here could be divided into 2 parts, right? So oopsie. Let's write that out. Yeah, let's write it out. This one is like kind of long. So that is 3/5 minus 1, and that gives you x to the 2/5, negative 2/5, right? Plus just 2/x, or you could even write that as twice the 1/x. That might be easier, right? And then that one shouldn't be too bad, so we're going to write that as it is. And that is 5 times 1/1 plus x squared. If you notice, I try to put the constant in the front, right? So that things will be a little bit, it may make more sense, okay? All right, guys, so let's keep going, shall we? All right, so now the antiderivative of this is what? You're going to add 1 to the negative 2/5, it's just 3/5, right? Which gives you x to the 3/5, oopsie, 3/5. Divided by 3/5 is actually 5/3, right? And the antiderivative of that, what derivative will give you 1/x? That should be ln of absolute value of x. Is that right? Right. Okay. So that is 2 ln of absolute value of x plus, I think if we're, it'd be sine of 2x, right? Because when you take the derivative of the sine, you get cosine of x, and you do the chain rule, will give you 2. Yep, that works. Okay. So next, what gives you the when you take the derivative of 1 plus x squared? Does that come to you at all? Yeah, it's tangent. Right? So if you said tangent, I think we're good. Sorry, inverse tangent, that is 5 plus inverse tangent of x. And then at this point, you should have been screaming at the screen saying, hey, you made a mistake here. Yeah, I forgot to put the c in the front, first one. Right. And then, and there should be plus c right here as well. Looks good? All right, guys. All right. And let's try one more. If you're looking at this right here, you should be thinking, in your mind, there's 3 to the x to the minus 4. Looks good? All right. So when we do the problem, I think that's clean, right? So f of x, capital F of x is what? X squared. And that's going to be minus 3 times x to the negative 3 over negative 3 plus c, right? If you clean that up, what do I get? Oopsie, I made a boo-boo. That should be small f of x, right? I didn't see that carefully enough. And then that will give me the negative 3's will cancel, but more importantly, let's look at that right there. So f of 1, when you plug it in, is 1 squared. That's a plus 1 to the negative 3 plus c has to equal to 0. And then that's 1, that's 1. So c is equal to negative 2, isn't it? Therefore, we could say that the f of x is equal to x squared plus x to the negative 3 plus, oops, that's minus 2. There you go, guys. All right, so those are the results that I have right there. Okie doke. All right, guys. Let's jump to the next page. Okay, here we go. How do I do this? Well, once again, as we did before, whenever you have an expression like this, there's a good chance that is inverse trig, right? To see that more clearly, you might want to write that as 4 times 1 over 1 minus x squared like this, okay? Yeah, antiderivative of 1 over x squared is inverse sine, isn't it? That's right. It's 4 inverse sine of x plus c. And then we have a initial condition, right? So f of 1/2 is equal to 4 inverse sine of 1/2 plus c is equal to 1. But what is this exactly? That is a theta, right? So let me put that on the side. That right there is a theta such that sine theta is equal to 1/2. That means the theta is equal to what? Pi over 6, right? And the theta just happens to be inverse sine of half. Okie dokie. All right. So you should be thinking this, or you could explicitly write it out, right? And when you do that, what we have here is 4 times pi over 6 plus c is equal to 1. Therefore, c is 1 minus 2/3 pi. Therefore, right, f of x is equal to, right, 4 inverse sine of x plus 1 minus 2/3 pi. Okay. All right, guys. And you need to show like pretty much every step that I just showed you. How about this one? Right. So we're looking for the position function, which is like s of t. So I need to find the velocity first, right? The velocity is what, when you take the derivative, gives you cosine, the sine of t, plus when you take the derivative gives you sine. Well, derivative of the cosine gives you negative sine, so it must be negative cosine t, right? So negative cosine t plus c. What you have to understand though is when you plug it in right here, v naught, that's a sine of 0 minus cosine of 0 plus c is equal to 5. That's a 0, but that's 1, isn't it? So c happens to be therefore 6. But I already know that when I take in, I'm going to have to take the antiderivative of the v, don't I? And we're going to put another c, so it could get a little confusing. So you can put a little subscript, right? Or you could call the next one d if you prefer, right? That's completely up to you. As long as you're consistent, I think this is fine. So we know that the v of t, therefore, has to be sine of t minus cosine of t plus 6. So now you know to find the s of t. That's part 1, by the way. That's part 2. Let's find the antiderivative of the velocity. Okay. So what, when you take the derivative, gives you sine? Well, we know that the derivative of the cosine is negative sine, so it has to be negative cosine t. And the word what subtract, what derivative is equal to cosine of t? That's a sine of t. And we got 6t plus c sub 2. Right? So we know that s of 0 is cosine of 0 minus sine of 0 plus 6 0 plus negative c2 is equal to 0. I know some of you guys like do all this in your head, and those of you who do that, I've noticed tend to make a lot of mistakes. I don't think the time that you save in writing less will make things better for you. Okay? So now this is 0, that's a 0, and that right there we know is negative 1 plus c2 is equal to 0. So we know that the c2 is equal to 1. Okay? All right. It's better to be safe than sorry. So try not to skip unless you're supremely confident. And then, not that you're confident, but there's evidence to back that up, right? So therefore, we know that the s of t is negative cosine of t. I'm basically reading off of this right here, guys, right? And minus sine of t plus 6t, and the c sub 2 is 1 plus 1. And don't get happy that you're done. Double check everything, right? Let's double check, shall we? Let's check this. So v of t is the derivative of that, which gives you negative sine t minus cosine of t plus 6. Take the derivative of that. S of t is equal to I'm sorry, why am I, it's a. The derivative of the v is a, right? Is what? I think I just made a small boo-boo, didn't I? Right. Because the derivative of the cosine is negative sine t. Negative is positive. That's right. Yeah, that's good. What's the derivative of the sine? That's cosine of t. Negative cosine of t derivative is negative sine of t. Good. Plus 0. And that'll give me cosine of t plus sine of t. And that checks out. Beautiful. All right, guys. All right. So let's go to the next question. The last question. Here it is. Baseball is thrown upwards of a height of 2 meters from the initial velocity of 10. So basically what this is trying to say right there, v of 0 is 10. Another way to think about the v sub 0 is equal to 10. Okie dokie. All right, guys. And this one is initial height. So h at time 0 is equal to 2. Another way to write that, h sub 0 is 2. Okay? Or h naught is 2. But I believe we're going to be using s. Usually in terms of physics, we tend to use the s for position. So that's what we're going to do. All right. All right. Let's do this. So we have at position 2, you've thrown up, it comes down like this, right? So maximum height occurs here somewhere. But we just need to be aware of what's going on, guys. In order to do this, I just start with something, right? We were not given an acceleration equation. So we just have to go with the fact that on Earth that we have the acceleration equation is negative 32 feet per second squared or negative 9.8 meter per second squared. I had to get used to using 9.8, negative 9.8, because when I was in college, we generally use negative 9.81. but I noticed that the most high school textbooks use -9.8, so we're going to go with that. Let's do this, guys. All right. So we're going to start with the fact that the acceleration function is -9.8 meter per second squared. We're not going to bother writing the units until the very end, if ever, unless we have to, right? But in physics, I'm pretty sure the physics teachers or professors pretty adamant about you including all the units, right? So v of t is antiderivative of that, which is -9.8 t plus c. Now, we sometimes use instead v naught, but let's develop that first, shall we? So we know that the v naught is equal to -9.80 plus c is equal to, according to the velocity, is 10. So that goes to 0. Yep, c is equal to 10. So in the future, you may just write that as a v naught. Okay, so you'll be okay to do that. So in the future, I'll write that in orange. You could say v of t is equal to -9.8 t v naught. I want you to write that first, and then we know v naught is equal to what? 10. Therefore, that is equal to -9.8 t plus 10. Okay, do not write this first. If you do that, you're gonna lose some points. Please don't do that. Okay. So you need to get the habit of developing the equations. Okay. So now that we have that information, so in a regular fashion, v of t, it should be written as -9.8 t plus 10. So this right here represents the shortcut that I'm willing to accept. Now, using this information, we need to find the antiderivative of that to find s of t, right? S of t. That will be -9.8 t squared over 2 plus 10t plus c. As a shortcut, I'll be willing to accept s naught, and then you could directly substitute it in. But I would wait until this becomes a habit, okay? So that's -4.9, 0 squared plus 10 to the 0 plus c is equal to 2. So that's a 0, that's a 0, so c is 2, right? Once again, that's the s naught. Therefore, s of t is what? -4.9 t squared plus, what is that? 10t, right? 10t, and the c is 2. And that is the correct answer. Okay, guys? Now, what I will not accept, I'm being fairly adamant about this. Do not, whenever you have problems like this, use the fact that you already know the fact that 1/2 of gt squared vt plus s naught, and that g depends on whether you're using meter per second or feet per second squared. Knowing this is okay to check your work, but do not use this from the scratch. The whole idea of this question is for you to develop this equation. All right, so I need you to develop it. Okay to use to check your work. Okie dokie. So it's kind of like you guys using L'Hopital's rules when you weren't supposed to. So be careful about this, guys, okay? All right, guys, that is it for me. So I'll see you in the next video. Bye-bye.